All right, so 2.6, we started the geometric proofs, okay? This one says copy and complete the proof. So the statement is that MA equals TH, and where do we think this comes from? This would be given. And then step 2 says reflexive property. So what do we think reflexive property would be? It would be anything that equals itself, right? Right? So if you look ahead, like if you look at the next step or the step after it, something like that, what's going to be reused? Alejandro.
AT equals AT.
Okay, so you see AT in number 3 twice. Do you see that? That's kind of your hint that that's going to be the one that's added to both sides. So that's where a reflexive statement would come. And then 3 is what we just said. So MA plus AT equals AT plus TH. So they took step 1 and they added AT to both sides, which is what property? Nope. Nope. Addition. Okay? I took this statement, right, and I added AT to both sides. When you add the same thing to both sides, that's the addition property of equality. You don't need to write addition property of equality. Just don't confuse addition with segment addition postulate. Okay, those are two different things. So for, let's say I had the diagram, right, and it said T and A was somewhere in it, okay, then MT would equal MA plus AT, right, which would be what? Segment addition postulate. And then step 5, took step 3 and step 4 and kind of combined them, right? In step 3 we said MA plus AT equals AT plus TH. And then we said down here that MA plus AT equals MT and AT plus TH equals AH. So what do we think our statement would be if we're using substitution? So that's step 3. Combine step 3 and step 4. Good. So step 3 was your addition property, right, which said that those two parts equaled each other. And step 4 was segment addition. And then they combined step 3 and step 4 using substitution to get to that last statement. On your test, you're going to get given a diagram. So I think diagrams are a little bit easier to work with, obviously. Unless it's a algebraic proof, then you don't need it. Okay. All right. Number 2 says use the given information to prove the statement. So this is your blank, open-ended. You've got to come up with the steps all on your own. So the given says that the measure of angle 1 plus the measure of angle 2 equals 90 degrees. And the measure of angle 1 is 59 degrees. And you're trying to prove that angle 2 is 31 degrees. Does that make sense, first of all? Yeah, why? Outside of a proof, how would you describe that to somebody that didn't understand it? If they both add up to 90 and one is 59, they'd be complementary, yeah, but if somebody didn't even know what complementary means. Good, like you can either say, okay, so if they add up to 90, then 59 plus 31 is 90, or if they add up to 90 and one of them is 59, subtract that, you get the 31. Does that make sense? So if you were describing this to somebody that really like maybe didn't understand this yet, that's kind of how you would word it. Now you got to figure out how to just get it into proof format. So what is my first step typically? The given. So I can write the measure of angle 1 plus the measure of angle 2 equals 90. You can even write both of them in the same step, okay, because they're both given to you. If you wanted to separate them out, you could. Then what? Who can give me an example of the next step? Alejandro.
59 plus the measure of angle 2 equals 90.
Good. So keep going. What'd you do after that? Perfect. Anybody do it differently? Because usually there's more than one way to do these. Yep. The final step, like, so your last step should always match the statement you're trying to prove. So you would always want that last step to have this as your statement, and then depending on your reason, your reason.
Is there another way to do it?
I think that's probably, I mean, you could have separated out your given. Yeah, I mean, you could have like moved your angle around. It wouldn't have been ideal, but it is possible. Sometimes people put more steps than they need. It doesn't make it wrong. Okay, that's the most efficient way to do it. All right, so look through both of the worksheets, the review worksheets that you did. So if you'll go to 2-3 first. So this was the one from Monday. And then we'll go to 2-5 and 2-6. So 2-3 was your law of detachment. So if we go all the way back to the beginning of chapter 1, 2-1 was your patterns, right? Making decisions or conjectures from a pattern. 2-2 was your if-then statements, converse, inverse, contrapositive, biconditional. All that stuff was 2-2. Okay? 2-3 was the start of law of detachment and law of syllogism. So remember, law of detachment was if you have an if-then statement and the if occurs, you assume the then occurs. And then law of syllogism was 2 if-then statements. So if you if you ran out of time on your homework, then you didn't submit it. If you didn't submit it, then you received a 0. That's 2 if-then statements. So if I put them together and said, if you ran out of time on your homework, then you got a 0, that would be using law of syllogism. Does that make sense? Okay. So number 1 said if the angle measures more than 90 degrees, then it's not acute. And then if occurs, right, an angle measures more than 90 degrees. So you assume that it's not acute. That's law of detachment. Number 2 says all 45-degree angles are congruent and angle A equals angle B. That does not lead to that they're 45-degree angles, right? If it said angle A equals 45 and angle B equals 45, then I can say they're congruent, and that would be law of detachment. But this time it's stating that 2 angles are congruent, which does not necessarily mean they're 45 degrees. 3 is also law of detachment. If you order an apple pie, then it'll be served with ice cream. Matt orders apple pie, so Matt was served ice cream. 4, if you wear school colors, you'll have school spirit. If you have school spirit, then the team feels great. Those are 2 if-then statements, right? And then the third statement took the if of the first and the then of the second and put them together. That's law of syllogism. 5, you eat too much turkey, you'll get sick. Kinsley got sick. Kinsley could get sick for a lot of reasons, right? Who knows? That's invalid. And then 6, if angle 2 is acute, then angle 3 is obtuse. If angle 3 is obtuse, then angle 4 is acute. So if angle 2 is acute, then angle 4 is acute. Syllogism. If you see 2 if-then statements and something is repeated, that's usually law of syllogism. That's how you can figure it out. All right, then it says decide whether it's inductive or deductive reasoning. Inductive is based on a pattern. Deductive is based on facts. So 7, Angela knows that Will is taller than Peter. She knows that Peter is taller than Natalie. That word knows tells you a lot. It's confirmed, right? Which would be deductive. And then it said explain your reasoning, and that could be in your own words, but that's logic or order or fact, something like that. 8, Josh knows that brand X computers cost less than Y. All other brands that Josh knows of cost less than X. So Josh reasons that Y costs more than all other brands. That's an assumption, okay, which is inductive. Number 9, for the past 3 Wednesdays, the cafeteria has served macaroni and cheese for lunch, so you assume it's going to serve it. That's a pattern. That's inductive. Questions on any of those? All right, 10, if you live in Nevada, then you're between the ages of 16 and 18, then you must take a driver education to get your license. Anthony lives in Nevada. He's 16 years old and has his driver's license. Therefore, he took driver's education. That is deductive based on facts. 11, he knows he does not do his chores in the morning. He'll not be allowed to play video games. He doesn't play video games. So the then is occurring, not the if. That's why it's invalid. If it said he knows he doesn't do his chores, he'll not be able to play video games, and then he doesn't do his chores, what can you assume? Then he doesn't play video games. That would be law of detachment, okay? But the fact that the then occurs is why it's not valid. There could be lots of reasons why he doesn't play video games. Number 12 says Katie knows all sophomores take driver's education in her school. Brandon takes driver's education, so Brandon's a sophomore. Again, the then is occurring, not the if. So Brandon may or may not be a sophomore. It doesn't say only sophomores take driver's education. Okay, if Dan goes to the mall, then he'll buy a pretzel. If the mall is open, Jody and Dan will go shopping. If Jody goes shopping, she'll buy a pizza. The mall is open. Dan bought a pizza. False. All you know for sure is he bought a pretzel. 14, they both went shopping. That's true. If the mall was open, they went shopping. 15, bought pizza. That's true. Jody bought pizza because the mall's open, and if the mall's open, she goes shopping, and if she goes shopping, she buys pizza. And then 16, Jody had some of Dan's pretzel. Who knows, right? She could not have. It doesn't state it by fact, so we don't. So that's false. Questions on any of those? Okay, 2-4 was the start of all those postulates. So it said to draw a sketch and illustrate each postulate. If two lines intersect, their intersection was exactly 1 point. Something like that would work. 2, if 2 points lie in a plane, then the line that contains them lies in that plane. You don't have to draw it twice. I just showed you the difference. 3, if 2 planes intersect, then their intersection is a line. Remember, there's a Quizlet with all these. If you're not too familiar with them yet, I put the Quizlet for all of Chapter 2, and the only thing, there's like 4 things at the end that aren't in there.
Do you have to know, like, postulate 11?
No, you don't need to know number. You just need to know what it says so that you can use it. Yep. 4, use the diagram to state and write out the postulate that verifies the truth of the statement. So E, F, and H lie in the plane. Through any 3 non-collinear points, there's exactly 1 plane. Points E and F lie on a line. Through any 2 points, there's 1 line. 6, planes Q and R intersect at a line. Any 2 planes intersect at a line. And 7, if points E and F lie in plane, the line that contains them lie in the plane. If 2 points lie in a plane, then the line that contains them lies in the plane. So notice none of them have numbers. I want you to actually write it out. Okay, 8 through 11 said use the intersection, or think of the intersection of the ceiling and the front wall of your classroom as line K. So if that's the case, then this corner here, like we're talking that corner, that top edge, is line K. Think of the center of the floor as point A and the center of the ceiling as point B. So kind of like where Fernando would be, underneath him would be 1 point and on the top would be the other. Is there more than 1 line that contains both A and B? Okay, false, 2 points, 1 line. Is there more than 1 plane that contains both A and B? Yes, they are collinear points, so there's an infinite amount of planes that contain them. 10, is there a plane that contains K and A? Yep, there's exactly 1 plane. That would be a line and a point not on that line, which is 3 non-collinear points. And 11, is there a plane that contains A and B and the front wall? Yes, okay? So it could be a plane that goes like straight from here down and over, right? It's going to contain all that stuff. All right, now you're using the picture to state whether the statement is true or false. 12 was true, 13 false, 14 false, 15 false, 16 true, 17 true, 18 false, and 19 false. Questions on any of those? 18. So 18 says FG and DE intersect. FG is here and DE is here. So the fact that that line is like grayed out means that it would be behind the plane. And so that they're like running like this. So they'd never intersect. So you got to be careful. Watch the dashes. The dashes mean they'd be behind a plane. So if that plane is running this way and the part of that line is dashed, it means it's going to be running behind the plane, and then the other one is running in front of it. 3-dimensional figures are probably one of the most challenging parts of geometry on a 2-dimensional piece of, well, an iPad, which is 2-dimensional, okay? Hey. Okay, 2-5 was the start of the algebraic proofs. Oh, sorry, Alexis, what's up?
Is it just what does the upside down 2 do?
Perpendicular. That means that where the 2 lines meet would be a right angle. So 1 is given, then distributive, then addition, then subtraction. 2, given, addition, addition, and division. 3, segment addition postulate, substitution, and distributive. 4, reflexive addition, angle addition postulate again, and substitution.
How is 3C distributed?
So the distributive property says, like, if you, like, think about it in reverse. If I were to do 2 times AB, then it would be AB plus AB. You're basically working in the opposite. You're taking out the 2 and making it 1 AB. Does that make sense? Yeah, okay. Okay, 5, both A and B are definition of perpendicular. And then 6 is substitution. And then it was your properties. So if you're given the property, finish the statement. Reflexive is anything equals itself. So angle B would equal angle B. Transitive would be the combination of 2 if-then statements. If CD equals GH. And you're trying to combine together the first and the last. So then GH would equal RS. Then CD would equal RS. Addition, if x equals 3, then 14 plus x would equal, so you're adding 14 to the other side. You could have either said 3 plus 14, or you could have simplified and said 17. Symmetric, you're just switching the order. If BC equals RL, then RL equals BC. And substitution, if the measure of angle angle A is 45, then 3 times angle A would equal 3 times 45. Yep.
3 times 45, or could you just actually do 3 times 45?
I'd give it to you if you actually multiplied it out. It's okay. So then 11 multiplication, if the measure of angle A is 45, and then you got to 15, dividing by 3 is the same thing as multiplying by a third. So remember, if it's multiplication, you would want to do 1/3. Question on any of those? Okay, so then this is where it got a little rough, and I went a little easy on you guys. Okay, 12, it said, if you're given the following information about the diagram at the right, if AB equals CD and CD equals OE, find the coordinates of points C and E. So you should have remembered the distance formula. This is hopefully making you review, but the distance formula would tell you that the length of that segment is 5. And so if I want to get from D to C and it's a vertical line, I'd have to just count up 5 points, and it should have gotten negative 3.6. Okay, if you put a question mark for 13, 14, 15, I actually did not take points off. Okay, so, but my recommendation is to try things. Plotting the points on that should not have been that hard. If it said to solve for t, this is something you could be doing algebraically. So for number 13, you had to get the equation and solve it for t. So I started with the equation which is given, distributed the point 11, simplified it by combining those like terms, and then subtracted the 4.95 from both sides and divided by 0.5. So the steps will probably be not as complicated on a test. You do want to know how to do the algebraic proof there. 14 says make a table showing the time spent walking for each of the following distances. So if I plug those values in to that equation, I would have gotten each of these. If I plug in 2.7, I got 45, 3, 39, 3.7, 25, 4.3, 13, and 4.5, 9. And then from there, made a table. So 15 is the plot of those points. And what you should notice about this is that as the time increases, as the distance increases, the time spent walking will decrease. So that's a great standardized test question. It will not be on your Chapter 2 test. So if you struggled with it a little bit, don't stress too much. And then same for 16 through 18. This is a great standardized test question, but it won't be on your test. You don't have to worry about sectors just yet. What it did say was that angle 1 plus angle 2 plus angle 3 plus angle 4 equals 360, which is what's true if it's a circle. And 2 plus 3 equals 200. 1 equaled 4 and 2 equaled 4. So if you took this step here and you said 2 and 3 were 200 and 1 and 4 were equal, you could have replaced 4 with angle 1, and that would have been substitution. And then you're at this step. So I would have had 2 angle 1s plus 200 equals 360. Subtract the 200, 2 angle 1s is 160. Divide by 2, and angle 1 would be 80, which means angle 2 is 80 and angle 4 is 80. Add those up, subtract them from 360, and you get angle 3 is 120. For the percent, you would say what percent is 80 over 360, which is up here. If you divide that in the calculator, you get 22.2 repeated. Same would be true for angle 1, 2, and 4, which leaves 34% left over for the last angle, angle 3. And then how many votes? So if you wanted to know what 22% of 315 is, you would do 22% times 315, or 0.22 times 315, and you'd get 70, which is true for angle 1, angle 2, and angle 4. And then, or candidate 1, 2, and 4. And then subtract that from the 360, or no, sorry, multiply the 34 times 315, and you get 105. Or add these 3 up and subtract it from 315, and you get 105. So again, good SAT prep question, not going to be on your test this time. And 2.6. So 2.6 was a little bit more in depth on the geometric proofs. So 1, the first 2 statements were given, and then because they both equal 9, you set them equal to each other. That's substitution. You went from, if you're using definition of congruent segments, you're going from equals to congruence or the other way around. 5 was also given to you, and 6 would have been transitive. If HI equals IJ and IJ equals JH, then HI equals JH. 2, first 2 steps were given. Then if they're complementary, they add up to 90. That's the definition of complementary. If they both equal 90, they equal each other. That's substitution. And then you took away angle 2, that's subtraction, and went from equals to congruence, which is the definition of congruent angles. 3, first step is given. Anything equals itself is reflexive. Added LS to both sides, that's addition. The whole equals the sum of its parts would be segment addition postulate. And then substitution for the last step. So this is just like the one from the warm-up. 4, so you're given all that information, that 4 equals 120, 2 equals 5, and 4 equals 5. If 2 equals 5 and 4 equals 5, then 2 equals 4 would be transitive. If you're going from congruence to equals, that would be the definition of congruent angles. And then if you know that 4 is 120, then 2 would equal 120. That's substitution. For 5 through 8, you wanted to set up your equation and solve it. So the fact that they were equal to each other in 5, I would set them equal to each other, which is substitution. And then subtract the 9x, and then add the 8, and then divide. For 6, the 2 sides are equal to each other. This time you had to use transitive. So if FG equals FJ and FJ equals JH, then FG equals JH is transitive. Then substitute the lengths of the sides, subtract the 3x, add the 7, divide by 2. 7ABD would equal DBE, and DBE would equal EBD. So again, transitive. Substitute in their equations. Subtract the 11x, add the 10, divide by 3. And 8, if KP equals PN and KP is 18, then PA equals 18, that's substitution. Then 7x minus 10 equals 18, that's also substitution. Add the 10, divide by 7, and you get x equals 4. Okay, so remember that I will be posting some extra practice on 2.6. You do not need to submit it, but it's definitely going to be good practice. I'll post the solutions on the same assignment. And then tomorrow we'll do 2.7.